Know whether a rod is charged or it is not charged, because we can see that positively charged rods and uncharged rods both can cause a decrease in divergence. Therefore, we have to deal with an increase. Therefore, the answer is that if both positively charged rods and uncharged rods will cause a decrease in divergence. Positively charged rods and uncharged rods both cause a decrease in divergence. We now move to the next question. Question number 3. State 2 properties of magnetic field lines around a magnet. 2 properties of magnetic field lines along a bar magnet. Anthony Nambiro. Anthony Nambiro, you had...
They are strongest at the poles. They are strongest at the poles.
That is correct. That is one. They are strongest at the pole. Someone else? Someone else? Someone else? Victor Mwiti, you have an idea? Victor Mwiti? Yes, Lesan Alan?
They are parallel.
Let us state they don't cross each other. They need not to be parallel. They don't cross each other. Austin Amboye? Austin Amboye, yes? Austin? Austin Amboye? Mohammed Farah? Mohammed Farah?
They originate from North Pole to South Pole.
That is it. They originate from North Pole to South Pole. From North Pole to South Pole. We can now move to the next question. Number 4. Figure shows an incomplete circuit for an electromagnet. Complete the diagram to show how electricity should be connected so that the polarities of P and Q are south and north respectively. In this case, P to be south, Q to be north. If I'm to deal with this case, let me just have the cross-section of P. Being like that, we can see this wire is moving over it like that, and it is coiling like that. So for this P to be south, then we expect the current to flow in clockwise direction. If it is clockwise direction, that is the direction. So it means that the current is flowing like that. So in this case, that is the flow of the current. If that is the flow, then it implies that this side becomes positive and this side becomes negative. So I've completed to show how a battery could be connected. Battery, you can either use one cell or several cells. It is going to be allowed. Then you go to part B. Yes, Ken Waroi, you have a question? Ken Waroi?
No.
Okay, part B. State 2 ways in which the strength of an electromagnet in A can be increased. 2 ways in which strength of an electromagnet can be increased. Kamal Austin, 1.
Increasing the length of the solenoid.
That one, it is the other way around, decreasing the length of the solenoid. In this one, it is U-shaped core and it is fixed. So the size of the core may not apply in this one. Ken Waroi. Ken Waroi.
The number of coils.
Increasing the number of coils. Increasing the number of coils is correct. Ian Muraivi.
Increasing the amount of current.
Increasing the amount of current. Increasing the amount of current. So we can move to the next question. So this one we have not covered, but I can just give you a concept on it. In a siren, sound is produced when a jet of air is directed perpendicular to a ring of holes on a rotating wheel. Explain the effects on the pitch of sound produced when the speed of rotation of the wheel is increased. Explain the effect on the pitch of sound produced when the speed of rotation of the wheel is increased. I want to give you an example of the wheel of a bicycle, the one with sprockets. You find that if you increase the speed of rotation, the pitch of sounds or the pitch of sounds is going to be increased. How does it work? What is going to happen is that the frequency of cutting through the air is the one that is going to be increased. Therefore, that increases the pitch. So the frequency of the sound increases, hence increasing the pitch. Hence increasing the pitch. Then we go to question number 6. Question number 6. State a reason why the current produced by a simple cell falls rapidly when the cell is being used. State the reason why the current produced by a simple cell falls rapidly when the cell is being used. Why do you think the current falls rapidly when the cell is being used? Yes, Anthony Nambiro. Anthony Nambiro.
It's because the chemicals are being used up.
They are being used up. So what is happening so that the current can reduce? That's what we want to get. The main reason we have two defects result to the current being produced lower. Abel Charo, 1. Abel Charo. Braningwe.
The main
local action.
Braningwe.
Local action.
Jenga. Din Jenga.
Due to polarization on the anode.
That is it. Polarization on the anode. On the anode. Another one. The other defects. Sami Moshiri.
Local action. Local action.
Local action. So those are the two main reasons that are going to result to the current being reduced. We now go to question number 7. Figure 3 shows a cell connected in series with an ammeter, a 2 ohm resistor, here it is, and a switch. A voltmeter is connected across the cell. The switch open, this switch when it is open, the voltmeter reading is going to read 1.5 volts, given that the internal resistance of the cell is 0.5. Determine the reading when the switch is closed. So do the working. Do the working. Meanwhile, for those I told you to write your full names, I'm removing your names from the page. So do the calculation. We'll see what we're going to have. So I'm waiting for you. So, Ferdinand Kavila, what answer are you getting? Ferdinand.
0.6 amperes.
0.6 amperes. Branningo, are you getting the same?
Yes.
Okay, let's work on the question. We want to determine the ammeter reading when the switch is closed. So in this case, we know the formula E is equals to I capital R, which is the external resistance, plus I in the circuit, small r. This formula can still be written like this. E is equals to I, we can see it is common here, factor it out. And we are going to have capital R plus small r. With this in mind, we can see when the switch is open, the voltmeter reads 1.5. So 1.5 being potential difference when the switch is open is the one we refer to as electromotive force. So E is 1.5. Is equals to I multiplied by capital R, it is 2. So this is 2 plus small r. Small r is the internal resistance, and you can see it is 0.5. So we are adding 0.5. In this case, we have 1.5 being equal to, this is 2.5 multiplied by I. 2.5 multiplied by I. Divide every side by 2.5, and finally our I becomes 0.6 ampere. 0.6 ampere. So that becomes our final answer. We now move to the next question. Number 8, you have not covered. Number 9, you have not covered. Number 10, you have not covered. Number 11, you have not covered. 12, not yet. Let's go to question number 13. Question 13. State the disadvantage of using convex mirror as a driving mirror. Disadvantage of using convex mirror as a driving mirror. Ferdinand Kavila. Ferdinand?
Yes.
Why? What is the disadvantage of using a convex mirror?
This is because the image you get is diminished.
So when it gets diminished, what happens? Click on Gary.
It is inverted.
Click on Gary.
The image is inverted.
No, convex mirror do not give inverted image. The driving mirror vehicles do not give inverted image. Yet,
Objects appear to be nearer.
Yeah, the object may appear to be nearer to the actual distance, so that will may tend to confuse the driver. So that is the disadvantage of using convex mirror as a driving mirror. We now move to, let me check another question of your level. Number 16. Define the following terms as used in waves. Number 1, amplitude. Amplitude. So lesson Kabila, what is amplitude? Lesson Alan, that is. What is amplitude? Ferdinand? Amplitude. Define the term amplitude.
This is the maximum displacement of a wave,
That is
either
it.
positively or negatively.
Correct. It is the maximum displacement wave from the mean position. You're talking about positively or negatively. Let me just clarify on that. So, for example, let's say this is the graph. And the mean position is this horizontal axis. The wave rises up and down, up and down. So this distance here, this distance here is the one that we refer as an amplitude. And we can see this positive amplitude. We have a negative amplitude. So the maximum displacement from the mean position is the one that we refer as amplitude. What about the wavelength? Wavelength, wavelength. Ezra Bradley. Ezra, what do you mean by the term wavelength? Mother Reginald. Reginald. Reginald.
The distance between the crest and the wave.
The distance between the crest
and wave.
Between the crest and what?
The distance between two crests.
The distance between two successive crests, or two successive curves, or between two particles which are in. Then we move to the next question. The figure below shows water waves approaching a straight reflector at a speed of 40 centimeters per second. Draw on the diagram the reflected waves. I remember we had told you to go through this topic so that you can be able to work on it before we meet. So we have to show the reflected waves. One thing you have to understand is that this source of wave, it is producing what we refer as circular waves. The circular waves, on striking the screen, they are going to be reflected. Once they are reflected, this part is the one that strikes this reflector first. So it will be the first to be reflected. This part and this one, they will be the last to hit the reflector, so they'll be the last to be reflected. Meaning that the resultant wave will be like that. So that is going to be the resultant wave. So that is our wave being formed. And I would advise you, when you're sketching the reflected waves, be using broken lines that you can be able to see. Then the other point to note, when you are showing the waves, the reflected waves, the distance from this wave to this one should be the same as for the original. The wavelength is not going to change. Then move to the next question. Given that the distance between the source and the reflector is 15 centimeters, we can be able to see 15 centimeters here. Determine the wavelength of the waves. Determine the wavelength of the waves. So I want you to work it out. So work it out. You can see from here up to here, the distance is 15 centimeters. So what is the wavelength? Kabila? What is the wavelength?
I'm not yet through.
Okay, another person. It's only that you have raised your hand.
Oh.
Okay, someone else? Brian Ingwe?
3.75 centimeter.
3.75 centimeters. Do you have other students who are still getting 3.75 centimeters?
Yes.
So,
Yes.
can Murray
Yes.
still getting this?
Yeah.
Yes, I am.
Okay, let's go through it then. We can see that from the source up to here, it is 15 centimeters. This 15 centimeters is divided by how many wavelengths? So we count the number of wavelengths. So here we have 1, 2, 3, 4. So we divide by 4 wavelengths, and we are going to have 3.75 centimeters. So that is going to be our answer, 3.75 centimeters. We work on the other question. Determine the frequency of the wave. Determine the frequency of the wave. So work it out. Branding, you are still raising your hands. First of all, work it out. Calculate the frequency of the wave. Calculate the frequency of the wave. The new participant have said, if you're not going to use all your names, I'm going to remove you from the group. So what answer are you getting?
10.6.
10.6. Kamau, you are getting that?
Yes.
In Jenga, you are getting the same?
Yes.
Okay, let's see
Yes.
how it is going to. So for now, we can be able to see that the speed is 40. So velocity is 40. If velocity is 40, then you can see here that the wavelength is 3.75. So wavelength is 3.75. So from the formula, V is equals to F lambda. Do the substitution. 40 is equals to F that we want to get multiplied by 3.75. So divide every side by 3.75, and our F is going to be 10.67 hertz. So that is going to be our final answer to that question. We move to the next one. For this one you have not covered. We go to question number 17. Question 17. Question 17. The figure shows a ray of light traveling from glass to air. Determine the critical angle of the glass-air interface. Critical angle of the glass-air interface. What is it going to be? Critical angle. Critical angle. Critical angle.
42.
Brand Macquarie.
42.
42 degrees. Simply it is this angle, because you can see that the angle of reflection here is 90 degrees. So the critical angle in this case is 42. Then you move to question number Roman 2, the refractive index of the glass. Do the calculation, find the refractive index. get the refractive index. If you are through, you raise your hands. Rafael Musioka, what are you getting?
1.49.
One. We are using the formula N, or refractive index, is equals to 1 over sine C. Sine C, where C is the critical angle. So this is going to be 1 over sine of 42. And this, so here we are having sine of 42, and then we get the reciprocal of it. It is 1.494. So it is 1.494. So that becomes the answer. You have to give it to 4 significant figures. Then you move to the next question. So we are moving to the next question. A piece of metal is embedded at the center of an ice block 15 centimeters from the surface of the ice. Given that the refractive index of ice is 1.32, determine how far from the surface of the ice block the metal appears to be. So work out on the question. Determine how far from the surface of the ice block the metal appears to be. Do the calculation. Once you are through, you raise up your hands. Anyone who is through? If you are through, lift up your hand. Edwin Wagakor, what are you getting?
11.36.
11.36. Let's see what we can get. What is 11.36 as what Edwin is getting for us. We know in terms of depth, the refractive index N is equals to the real depth, and you have to write in full in exams, over the apparent depth. If you want this formula to be marked, it has to be in full, not initials. So we can see the refractive index is 1.32. So 1.32. The real depth is the actual length of the block, which is now giving us 15 centimeters. So it's equals to 15 centimeters over the apparent depth. This depth that appears to be, and actually it is the question, how far the surface of the ice block the metal appears to be. So we get that apparent depth. So this apparent depth is equals to 15 divided by 1.32. So we have 15 divided by 1.32, and I'm getting 11.36. So our final answer is 11.36 centimeters. So that becomes our answer to that question. We can now move to the next one. So this one we have not covered. This one we have not covered. So we are through with that paper. Let's now go to another paper. We discuss about Newton's laws of motion, where we left last time when we were together. So we are Newton's laws of motion. We were through with the first law. So we are starting with the question number 15. Question 15. Work out on question 15. Once you are through, raise up your hand. Question 15. Question 15. Cephas Mutu, are you through? Who is through? If you are through, lift up your hand. Question 15. Waiting for the answers. Still waiting for the answer. Mm-hmm. Lewis Nganga, you are through? Lewis Nganga, are you through? Lewis Nganga?
No.
Still waiting for the answer? Okay. We have waited for too long. Let me just work on it. So in this case, we have a link with the power and it is affecting us, so just bear with the situation for now. So a bullet of mass 22 grams traveling at a velocity 18 meters per second. This is the first velocity, just referred as the initial velocity of 18. It penetrates sandbag and is brought to rest. If it is brought to rest, then it implies that the final velocity in this case becomes 0. After of 0.6. 0.6. Having gotten this, you cannot be able to work out if you don't have the acceleration. Remember that the three laws and three linear motion formulas, acceleration is there, so you have to get acceleration. So v minus u over t. So in this case, it becomes 0 minus 18 minus 18 over time of 0.6. So negative 18 over 0.6 or negative 180 over 6, that is going to give us negative 30 meters per second squared. But our intention is to get the depth of the v squared is equals to u squared minus 2as. 2a, you can see that you have a problem with power on my side. V squared is 0 squared. So here you have 0 squared is equals to u squared, that is 18 squared, 18 squared minus 2a, and you can see a is negative 30 times s. So negative and negative is positive. So minus 2 times minus 30 is 60. So with this one in mind, then we want to get our s. So our s becomes 18 squared divided by 60. So 18 squared, we are dividing by 60, and you get 5.4. So the bullet is going to penetrate through a length of 5.4 meters. Then the other question, the average retarding force on the sand. We know F is equals to MA. Mohammed Farah, there is background noise coming from you. Please kindly mute yourself for now. Then from there, we want to get this force, and our F becomes the mass being in grams, converted to kg divided by 1,000, and you get 0.022, 0.022 multiplied by A, and our A already we got is negative 30. Negative 30. So if you work out, this is going to give us a negative. So 0.022 multiplied by 30, we get 0.66. 0.66 newtons. So the force, of course, it has to be negative because the body is decelerating. Then we move to the next question. Because of air resistance and friction, what force of 2,500 newtons is needed to keep the lorry traveling at a steady speed of 20 meters per second? What power must be provided by the engine? Work out in the calculation. Find the power that should be provided by the engine. Work it out. Brian,
125 watts.
Pardon?
125.
Pardon?
125. Yes.
Okay. So you have some. Do you have some other students who are still getting 125? Now, because the question is asking us to get the power, we know power is the rate of doing work. And power being the rate of doing work, power is equal to force, that is work done, force times distance over time. But distance over time gives us velocity, meaning that power is the same as force multiplied by distance over time, which is velocity. We can see that the force here is 250 newtons, 2,500 newtons. So 2,500 newtons. We multiply by the velocity of 20. So this is going to be 25 times 2, that is going to be 50. And then followed by 3 zeros. So it is 50,000 watts or 50 kilowatts, it can be allowed. So that is how we can work on that question. Then we can move to question number 17. A bullet truck moving at 250 meters per second hits a tree and slows down uniformly while penetrating a distance of 12 centimeters. Determine the force exerted on the bullet to bring it to rest. Determine the force exerted on the bullet to bring it to rest. Do the calculation. So we are in question number 17. Question 17. Waiting for you. Still waiting. If you are through, lift up your hands. Number 17. Anyone who is through? Remember, I said that if you don't use your two names, I'm sorry, I'll be removing you from the group. Anyone who is through? Lesson Alan, what are you getting? Number 17. Lesson?
I'm not through yet.
Pardon?
I'm not through yet.
Not through. Okay. Let me assist you. Remember, you're still learning. I can guide you. We shall still have other questions that you're going to attempt. A 3-gram bullet moving at 350 meters per second hits a tree and slows down uniformly while penetrating this distance. Determine the force exerted on the bullet to bring it to rest. So you have to bring it to rest. It is moving at this velocity. The initial velocity U is 350. 350. And because it is to be brought to rest, it implies that the final velocity is 0. I would advise you to be writing the quantities first. And it is going to penetrate through this distance of 12. So the distance S to be penetrated is 12. So because we asked to determine the force, and in order to get the force is equals to MA. We have our M as 3, but we don't have A, meaning from this equation we can be able to get A. So we don't have this A. I mean, we don't have our A, sorry. So because we don't have this A, it is the one that we expected to get. Therefore, we are using the formula V squared is equals to U squared plus 2AS. So V squared 0 squared is equals to U squared 350 squared 350 squared plus 2A, we don't have it, times S. S is in centimeters, you have to convert it to meters. So 0.12. Therefore, this becomes 0.24A. Bring it to the other side, it becomes negative 0.24A is equals to 350 squared. 350 squared. So this means that our A is equals, so we have 350 squared divided by 0.24. So this is going to give us 510 for 17. Negative 510 for 17. So we come now to this formula. F is equals M, 3 grams converted to kg, becomes 0.003 multiplied by 510 for 17. If you work out, then our F finally is equals to So our F becomes, we have 0.003 multiplied by that value, and I'm getting 153, 125. So that becomes our final answer, newtons. Then we can move to question number 18. Question 18. Oh, sorry. Roman 2. What assumption did you make in answering Roman 1? What do you think could be the assumption made in answering Roman 1? Yes, Zach, KG?
The assumption would be that the final velocity was 0 meters per second.
Of course, it will be 0. That one is not an assumption, it is a fact. Let me reach to a point where it is going to rest. So it may not be an assumption. Someone else? Dean Jenga?
The mass remains constant.
The mass, of course, remains constant. That one is a fact. Abel Taro?
The body or the bullet did not experience the friction force due to
Okay, let me assist you. In short, the bullet is not losing any energy. We are assuming that there is no energy lost in the formation of the bullets, in causing the heating and sound, so that all the energy now will be used towards forcing this bullet to penetrate through a tree. We now go to question number 18. Question 18. A horizontal force of 12 newtons is applied on a wooden block of mass 2 kg placed on a horizontal surface. It causes the block to accelerate at 5 meters per second squared. Determine the frictional force between the block and the surface. So work out on that question. Determine the frictional force. So work it out. We are in question number 18. Question 18. Waiting for the answer from you. Sami Mushiri, what are you getting?
2 newtons.
Pardon?
2 newtons.
Sami Mushiri, I can't hear you.
2 newtons.
2 newtons. Do you have some other students who are still getting 2 newtons?
Yes.
Do you still have some other students who are getting 2 newtons?
Yes.
Victor Ikua, what are you getting? Victor Ikua, Klein Dongo?
2 newtons.
Niko na kupika sasa, nilikuwa nataka lesson niko na nimeona mwalimu hayuko. Sasa nilikuwa nataka kupika ukakuja. Nataka kujitolea.
Never motivate. Motivate.
No, yeah. No.
Welcome to our first episode of Guru. Yeah. What did you just say?
Aye. Ngoja. Sigara. Sikimodiki.
Yeah.